So let's create the ball so we can see that it works in here. So if we say that we have static walls, these shouldn't move. And the other types that we have is kinematic and dynamic. The dynamic bodies are affected by things in the world. That means that our ball will now be a dynamic body. So to follow our pattern here, I have a body definition. Call this my ball body definition. B2 default body definition. The ball body def dot type is going to be a B2 dynamic body. That means it's being affected by other things in the world, colliding with other dynamic bodies or kinematic bodies, and also colliding with statics. Let's place this ball somewhere in our scene. So the position is going to be 8. And then for the Y, we can do 6. That'll put it in the middle of our world. Then we have a B2 body ID. Call this the ball ID. B2 create the body. We need to give it the world it belongs to. And then the ball body definition. Just need to remember to put the correct symbol there. All right, so there we go. We have our body here. Up next is the shape config and geometry. So B2 shape definition, ball shape definition. And we can instantiate this with a default shape definition. I don't need anything on this shape definition just yet. I will take a look at some of the sensor and collision configuration later. I need the geometry. So this is going to be a B2 circle, ball geo. I can simply initialize this with this an empty object notation. One thing that we need on this ball geometry is the radius, and this is in meters. So I'll make this 0.5 meter, which means that in SFML that translates to 25 pixels. Up next is going to be the shape ID. So our ball shape ID is going to be B2 create, and this is a circle shape. Give it the body that it belongs to, which is this ball ID up here. We need the shape definition, so ball shape def, and then also the geometry, so the ball geo. And there we go. We have our shape config and our shape geometry. Next up is a circle shape from the SF library here. I'll just call this my ball. Takes in a single parameter here, the radius, or a radius and a size. And we'll just specify the radius. And for this, it's going to be 25 pixels. Then, the same as with our walls, we have a set origin method. And for this, we can simply pass in the radius. That'll put it at the center of our circle. So if we draw this again, if I instantiate a circle like this, then if you imagine a sort of cube around this circle, this is the bounding box, then the origin is going to be up here, but I want it in here. If I move 25 units inwards, then that's going to put me at the center here. And then 25 units down, that's going to be the center here. So if I move the radius length inwards and downwards, then it puts me at the center of this geometry. So that's why using the radius to specify our origin works. All right, let's see here. Let's put one of these methods to use. I'm going to take this Box2D to SFML. I'd like to put this circle set position at the location of this ball body definition. So we have this position here, and we can now use this. So I'm going to use a B2 vector. So that means B2 to SFML. Now I simply need to get my hands on that vector. It represents this position. We have this B2 body group of methods. This is all related to the bodies. We have a get position here, and it takes in that handle that we have. So our ball ID, and that's it. We have this ball we set the position and we convert the vectors. And let's draw this. So I'm going to draw the ball shape here. Because our Box2D and SFML are separate constructions, or they're separate within our program, we need to update the ball position after every update step of our physics simulation. So that means I can pretty much just take this code, and then after we step through our physics simulation, we now need to set these things up. We need to keep them in sync. So here we go. We have this ball set position, and then we simply convert the position from Box2D to SFML. So let me run this. And we see that nothing's going on. And that's because on our body definition here, we can actually set up a linear velocity, and I simply want this thing to move in some direction. So I'll make it move 5 units up or down. Now if we run this, we see that it's doing something, but this is it's moving into the wall there. And I think my southern wall here, there's something wrong with the config. It might be because of this. This is the size. This isn't anything else. So I'm going to take 50 again. All right, so I found some issues. The first one was here. I put the position in here where it was supposed to be the size, and then also I swapped out the literal position here, and I'm using the conversion. I can actually do the same thing up here. We can start to use all of this Box2D methods. So there we go. If I run the simulation, it's going to move downwards and then just sort of stop right there like a beanbag. Let's see here. Let's take a look at another piece of configuration that we have. We have this shape here. Now, when we think about the shape in Box2D, that tells us how is this geometry that we specify with this circle, how is it going to interact with everything else? If I want to control something like the bounciness, this is exactly where it needs to happen. So we have a B2 shape, and then we can set some stuff on here. The thing that I want in this case is restitution. This controls the bounciness of this thing, but we also have the friction in here and some user data. These are all pretty useful. But for me, I want this restitution. Then I pass in the shape ID. So it's going to be this ball shape ID. And then just set this something to like a half. It's a value between 0 and 1. But there we go. We see that when it collides with the wall, because of that restitution, it's now bouncing between them. Because it's set to 0.5, half of the energy is absorbed by the wall, and the other half is used to ricochet this ball. If we set it to 1, then it will pretty much always bounce around. See, there's no loss of energy here. All right. But with that, we now see that our walls and our ball are working pretty much perfectly. And we've also taken a look at some of these conversions. So let's take a quick summary here. In this video, we covered the ball. So we set up our body definition. So the physics entity within our physics simulation has got nothing to do with the shape or the geometry or anything. That comes in here with this shape definition and the geometry. So the geometry is separate from the shape definition. The shape def tells us how this thing is going to work within our world, and then the geometry is the area that it covers. And we set up some restitution for that shape, controls the bounciness, and then finally we have our SFML shape. Box2D and SFML are still separate. That means we need to keep them in sync. And for now, it's just going to be as simple as setting the position of our graphic to the converted position of our physics entity.